Go.
Good morning, class. How are you guys this morning? Okay, according to the life course of life, we are to be discussing this morning pressure and volumes. Each one of you have a student's notes, and worksheet. Let me share the worksheet. So in the student's notes, in front of you, we will go through everything that will be, we will be going through everything on pressure. And if you could open your worksheet and put there on the board, the projector, there are three objectives we will be looking at today. Three things we will be looking at. Yes, we will be defining pressure in the term of force and area formula. Do you know what SI means? Anybody know what SI means? SI unit? What SI means? The standard international index, right? It has to do with the standard that has been used around the world. And lastly, we will explain how pressure principles, including Boyle's law, in gases, are applied to particular trade work, and we will work some problems using scenarios within the engineering field. So I want somebody from the student's notes say what is pressure? The definition of pressure. What is pressure? Yes, go ahead.
Pressure is the force applied on a surface or a unit area.
Yeah, very good. So pressure is, if you check here, pressure is the force applied on a surface or a unit area. It needs to be explaining that pressure is a force that you apply. Take for example inside the workshop, you apply a force by hammering inside the workshop like a piece of steel. You take a metal hammer and you use a force and you apply a strike on a piece of material. Pressure there is being involved and it's on a certain area on that material. Notice what is there on the board. What is the formula for pressure? We said that pressure has to do with force and area. So therefore pressure is equal to what?
Force over area.
Or force divided by area. It's being said that, and you see the formula. Let me show you the formula. You see the formula there inside of your on your worksheet. Pressure is equal to force divided by area, and we said P, which represents pressure, is equal to F, which is force, over A, which is area. Now, what is the unit for pressure? You see what is the unit for pressure? They say pressure is equal to Pascal. Pascal. But then take a note that force is equal to, is measured in newtons, and area is measured in square meters. Note how square meters is being written as m to the second square. Now the set pressure is equal to force divided by area. Now how is it that pressure is equal to Pascal? Therefore, Pascal is equal to what? Pascal is equal to what? Pascal is equal to 1 Pascal is the same as what? Newton over meter squared. So 1 meter divided by meter square is equal to 1 Pascal. Right, and that is measured. If you go to the unit area that is being there on top of your worksheet, you see what's said here? Force is equal to Newton is measured in Newton, meaning a push or pull, or it could even be a pound as we explained. Area is meter square, which is the surface which the force is being applied or acted on, and pressure now is equal to Pascal, which is 1 Newton per a meter square. Is that understood? And you want me to go over that again? Okay, that's good. So we can move ahead. Now let us work over and let us use the example in the engineering field. Now all of you are millwrights. I'm using millwright in the millwright field, the fitting and machining, and you guys will come up with certain examples that pressure is being applied. Even in the mechanic field, take for example a situation like this: a car tire pressure. Explanation there. High pressure is needed to support the load. Now what happens if the wheel is soft? What we said when the wheel is soft? Or he said that the tire don't have enough air pressure. So for us now to get the vehicle well supported, we put in some pressure here inside of it, and thus enabling the vehicle to able to stand up. What about a hydraulic lift? You ever see a hydraulic lift? Give me an example of a hydraulic lift. Yeah. You see that lift that is lift up the vehicle? I guess some of them, when you use your foot and you press it, the seat starts to move up. And then we have the one that is normally in a lot of car windows, turn like that. But that's mostly a screw one. But the hydraulic one, meaning it is being pressurized by means of air. You see what it said there? It said a small force. You see how it's be like a small unit, a small like a jack up a vehicle, a hydraulic jack. It's a small unit, but you see how it's able to lift a car, and some of them able to lift a truck. Take for example, even those hydraulic lifters within the auto shop. You guys will be around in the shop there. You see how that unit stay, but it's able to lift a big heavy machine by use of hydraulic pressure. So that's another example of pressure. Now cutting with tools. Sharp blade creates high pressure because the area is being small. And you persons that is inside of the fitting and machine shop, you know about that. Another situation, they go to the welding and torch gas pressure. Because of that controlled pressure, it ensures that proper gas is being flowed through the torch that is being used to do cutting in the welding shop. You guys ever see how they cut with the cutting torch in the welding shop? You ever see an example, a practical demonstration of that? Well, in time to come, we will venture off into the workshop and do all of that. So key points. What are some key points you needed to take into consideration so far? What are some key points?
Smaller area, higher pressure, or the same force. Larger area equals lower pressure.
Yeah. So you see the answer. So explain, somebody explain. Smaller area is equal to what?
Higher pressure.
Higher pressure for the same force. A large area, low pressure is being applied. Now how can we solve some problem using force over area. And you body, what is the unit for force? Do you remember what's the unit for force? Who could help you? Who would like to help you? The unit for force is Newton. And the unit for area is square meter. Therefore, pressure is equal to, the unit for pressure is Pascal. And 1 Pascal is equal to and I want you guys to think like this. 1 Pascal. 1 Pascal is equal to 1 Newton per meter square. Per means divide. And in engineering, if you guys venture into the engineering, or if you guys, after finishing here, you guys choose to do engineering at the University of Guyana, or even if you wanted to go into technician, mechanical engineering, these are some terms you will be reaching up with again, or units you will be reaching up again, and you will expect to use engineering language. Per Newton per meter square. So these are things you guys need to remember, right? So let us do a question. Let us do an example. Know there, it said there, an hydraulic press exerts a force of 400 Newton on a piston with an area of what? 0.02 meters squared. Find the pressure. Find the pressure. How do we solve those kind of questions? What's the first thing we do? Could you remember? What's the first thing you do? You do what? You put down your data. You put down your data. So the data is, and what's the first thing in the question? What's the first force? And the force is equal to how much Newton? 400 Newton. And then we have what? Area? 0.02 meters squared. And what we find for pressure? And you put a question mark here. You put a question mark at pressure. And we say pressure is equal to force over area. So pressure now is equal to how many? 400 Newton over 0.02 meters squared. And what do you get when you calculate what you get? You get 20,000 Pascal. Right? 20,000 Pascal. See how easy that is? Let us do another example. What's the other example? So this time we ask to find for force. You can come in. We are asked to find for, this time we ask to find for force. So, same thing. Closing the door, so so this time we are giving no force. That's what we asked to find for. And what is it we asked, what is it given? Given the area which is 0.1 meter square. We given the pressure. The pressure is how much? The pressure is 30,000 Pascal. So we write down Pascal and pressure is equal to force over area. And we get, we put in the units now, which is 20,000 equal to question mark, which we can put forth, and we get 0.1 which is squared. How do we solve that? How do we solve that? Now this is divided. When you come over to the other side, it will be multiplied. So therefore, 4 will equal to 20,000 multiplied by 0.1. And that will give you what? 2,000. Right? And everything there is on the worksheet. Just to let you guys know, the worksheet basically we do ones for your sake. And what I want you guys to do, I will want you guys to please put it into your exercise book. Put what's there on the worksheet in the exercise book so that you guys will remember. So what I would like you guys to do now, since we have understand what is pressure, do an example of what is pressure. We know what is how do we find for pressure. We know what are all the units involved in pressure. Fourth, what I want you guys now is to look at your worksheet given. Look at the worksheet. So not the worksheet. Look at the question sheet given. You see the question sheet given? Go ahead, listen. Now, if you guys check your worksheet given, there are 4 questions asked here. And the 4 questions asked here, which I will now test you guys' knowledge on what we are already discussed. So what you will do, you will write your name on the sheet that you will be answering the question and 2 on the worksheet. Put your name and you'll simply answer the 4th section, which is the first question. You will follow the question out and then you guys will write it down, right? So what's the first question there on your worksheet? Define in your own words pressure. I know that it said there is the right thing, but I want you guys to define it in your own words. How is it defined?
80 minutes.
Just define in your own words what is pressure. I give you guys 2 minutes to get that done. Then when you guys finish with that, then you guys can state the formula for pressure and its SI unit. And its SI unit. Then you will tell me why does a sharp chisel better than a dull one. You understand that? Why do a sharp chisel better than a dull one? And then finally, in a hydraulic system, how could a small piston lift a heavy load? How do a small piston lift a heavy load? So instead of 2 minutes, I give you guys 5 minutes to get that started out. Yeah, no problem. the policy in the building. So you guys supposed to finish, right? Yes, you guys finish. So we gonna go through the first exercise, which is one. What was the question again? Define depression in your own words. What is your definition? Pressure can be built up by air. Maybe your definition. Force applied to a surface, a shark. Let me hear you, Paul. Come on, Paul, let me hear you. Let me hear female. Listen about it. What's your definition?
Force is,
She get the same definition, you must involve in your definition a surface area, a certain area, or so which area, in which part or which area the force is being applied to. It is on a piece of steel, it is on a piece of wood, so area must be involved in site and force. So good job, students. So you guys know, everyone knows what it is. It is on the board. That is the formula for pressure. So that should be an easy one. We come to a little more difficult one. Why does a sharp chisel cut better than a blunt one? Yeah, go ahead, Melvin.
less force is needed.
Yeah, answer that answer. Another person. Another person. Now when you take a look at the sharp chisel, that is dull one, which has a smaller cutting surface, the sharp one. And because of that fact, it will produce higher pressure, right? Because the sharp chisel has a smaller area that is that is carrying out the job. It will produce higher pressure and you will get better results. Right? So you get good results from a dull chisel. Or let me use a dull knife in the kitchen. A dull knife. You will not produce a higher pressure. Now the last question, in an hydraulic system, how can a small piston lift a heavy load? You can think about a jack. So how would that happen? And anyone give me a simple explanation? You start over here. Could you give me your simple explanation? How do a small piston can lift a heavy load? Alright, let me help you guys with that. Well, a small piston applies pressure through fluid, right? Through pressure through fluid in the piston, which transform into a larger piston, creating a greater force. So due to that pressurized system with the oil and the piston now, when pressure is being applied to the fluid, now the piston is able to move up. Now a car is able to be lifted. A truck, even a truck is able to be lifted due to that system, that pressurized system. So if we are to sum up what we discussed so far, how could we sum up what we have done so far? How can we sum up what we've done so far? Can we sum up what we have done so far? We'd like to sum up what we have done so far. We were able to see what is the definition for pressure. Be able to discuss a formula to find the pressure. Be able to see the unit for everything involved in pressure, force, and area. And to be able to see real-life example of it being applied. So in our next class, we will go into more as respect to more calculation in pressure, and we will discuss the volume as it has to do with Boyle's law. So I must thank you students for this lesson. So you could take a quick break, and then we will come back and have our discontinued discussion. So thank you, students.